Well, good evening. Welcome to Space Oddities. How are you all out there in YouTube land? Welcome to the show. Back with our Tuesday evening live stream. I'm joined this evening by Tom. How are you, Tom?
Very good, Andy. How are you all doing?
Good. Roger?
I'm fine.
Good. Michael?
Can't speak for everyone else.
Well,
Fine,
no, right.
Fine, thank you, including the boot.
Yes, Michael's still got the order of the boot, so
Yes.
still recovering from his broken bone.
Yes.
And Lou, how are you, Lou?
Oh, life is grand. Spring is clearly here
Ah,
on the east coast of the U.S.
wow.
Oh, I was thinking that about Catalonia this morning. It was a beautiful morning, but we're catching the edge of a big low pressure area over central France, and now it's peeing down with rain with high winds. So anyway, horses for courses. It is what it is. Thank you all for joining us. Thank you all for joining us on this Tuesday evening. Let's see who we've got in. We've got Stuart. Hi, Stuart. Hi, Ian. Hello, Anne. Hope you're both well. Who else have we got here? Nobody's actually ventured to put their name in the chat yet. So, Gerard, thank you so much for your generosity, sir. As always, much appreciated. And Lee's here. Hi, Lee. And who else have we got here? Alan's here. Hi, Alan. And a few others. So there we are. So what have we got for you on tonight's show? Well, in July this year, it will have been 10 years since NASA's New Horizons probe flew past Pluto. So Lou today is going to be telling us what exactly we now know about the mysterious world of Pluto compared to what we knew before the flyby. And we hope to follow this up with further programs in the year about the Pluto encounter, because it was a major triumph for planetary science and for NASA, of course. So Lou's going to be telling us all about New Horizons. Also, this evening, we're going to be looking at some of the upcoming moon missions. Michael's going to be talking to you about the Blue Ghost mission, which is now in orbit around the moon, having got that far at least. Yep. I'll be talking to you about Intuitive Machines IM-2 lander, which is launching this week. And we will have all sorts of other stuff. Usual gallery and night sky guide from Roger. And Roger this week is going to be doing the constellation of the week. So there we are. So that's what we've got lined up for you this evening. Just to start off, I'd just like to remind you that we do have quite a packed week on Space Oddities this week. We've got several missions launching and landing this week. So do stay with us. And I'm just going to give you a quick roundup of exactly what we have going on the channel this week, so you'll know when to set your alarms for. So just give me 1 second, and we will have a look at this. So this week we have got on our YouTube channel, we've got the launch of Ariane 6. We've got Starship's Test Flight 8 coming up. We've got, on the 1st of March, we've got the launch of 2 new NASA telescopes, Sphere X and Punch. The 2nd of March, we've got the landing of the Blue Ghost lander on the moon. And as I said, we've got the launch of the IM-2 lunar lander on the 27th, which I think is 2 days away. Yes, on the 27th. So do keep an eye on the website. That is to say, spaceoddities.space, and also on the YouTube channel, because the dates and times of these missions may vary. So do keep an eye on the channel to see when things are actually happening. But we do have quite a busy week coming up. We're going to bring you as much coverage going forward as we can. It's going to be the year for a lot of lunar exploration. A lot going on with the moon this year, which is really exciting because, you know, in years gone by, there was nothing or very little. But this is really packed as far as the moon goes. And we will, of course, keep you up to date with everything that's going on. Speaking of the moon, don't forget that April on Space Oddities is Moon Month, where we're going to be bringing you a whole range of live streams, videos, podcasts, all sorts of things we've got planned for April, all related to the moon. And what we thought was, you viewers may have some stories about the moon that you may want to tell us about, whether it's to do with mythology or legend or factual things about the moon that you don't think people know about, or anything you find interesting about the moon. Drop them in an email and address that email to moonmonth@spaceoddities.space. That's moonmonth@spaceoddities.space. And at some point during the month, we will, of course, feature it. We haven't worked out exactly what's going to be what we're going to be doing when, so we've got to put a schedule together yet. But when we've got most of the content together, we'll do that, and we will let you know exactly what's happening during Moon Month. And we want to do a Moon Month because, as I said, going forward from this year, there's going to be a lot of lunar exploration going on by, at the moment, 13 different countries. So we're going to do a special all about the moon. We're going to be featuring the Apollo missions. We're going to be featuring past missions to the moon, all sorts of stuff we've got going on for Moon Month. So do keep your eye on the channel. And as we get further towards April, we will, of course, let you know exactly what's going on. Don't forget, of course, that if you'd like to support us in all our efforts, then you can do so by buying us a coffee. And you can scan the QR code here, or you can click the link in the chat to go and buy us a coffee. And as I always say, because I have to say it really, just in case anybody accuses us of wanting to become millionaires from your money, no, all the money goes back into the channel to keep it running. So any contributions in caffeine would be greatly appreciated. If you would like to make a donation directly, you can click the super chat icon under the chat window, the one with the $sign on it, which will allow you to make a donation directly to Space Oddities. And lastly, the Space Oddities shop is still open. Wonderful merchandise, hoodies and t-shirts available there. Fly the flag for Space Oddities. Beautiful quality merchandise. We wouldn't have offered you anything else, of course. So you can again click the link or scan the QR code here to go directly to the Space Oddities shop. And they make wonderful presents, if nothing else. So if you've got anybody's birthdays coming up, why not buy them some Space Oddities merchandise? And they will thank you for the rest of their lives, believe me.
Yes, so, and all those Space Oddities flags and logos are right side up. I just wanted to make that comment.
Absolutely. Yes, that's definitely worth saying. So there we are. And, astronomers' lives matter. So, support us in any way that you can so that we can keep this channel going and keep bringing you the universe every week, which we would absolutely love to do. But, of course, we have to finance it somehow. So any contributions are fantastically appreciated, more than you'll ever know. So there we are. Okay, well, I think we'll move on because, as usual, Lou has to leave us before too long and go off on another teaching expedition into the darkest depths of the classroom. So I'm going to hand it over to Lou now, and he's going to be talking to us about Pluto.
Yes, darkest depths of the classroom. That's well put. Well put. Oh, and Andy, we should be, I think each week we should be reminding our viewers that there will be that move to daylight savings time is out of sync between Great Britain and the United States. Is that right?
That's correct. As of March the
March the 9th for the US.
Yeah, March the 9th in the US. That's right.
And March the 30th in the UK.
Okay. You don't have to remember. We'll remind you. One of my students is on here.
Oh, really?
Yep.
Hey,
Great. Yes, I handed out the SpaceOddities business card. So good for you. Good for you.
Ah, Gilly Billy, or is it Jilly Billy? Don't know. Forgive me.
I'm not even sure who that is, but that's okay.
I
Moving
seem
along.
to know you, Lou. Your notoriety precedes you, sir.
Yes.
So there we are. Well,
Story of my life.
Gilly Billy or Jilly Billy, whichever one it is, thank you for being here. You're most welcome to Space Oddities, and thank you so much. Lovely to see you. We hope you stay as a regular viewer. So there we are. Okay, Lou. So yes, so this year it is 10 years since New Horizons at Pluto. Can't believe where that time's gone, but it is nonetheless a decade since that amazing mission, which completely transformed our view of Pluto, because it turned out to be not the world we were really expecting. Far more interesting, I think, than what we were expecting, because I think, didn't everybody sort of expect Pluto to be a frozen ball of ice with not much activity going on?
In a way, that's true, but we have learned from other planetary missions, such as Voyager and Cassini and so on, that the solar system is not what we thought. So we are surprised, but we were prepared to be surprised. I guess I could say it that way.
Okay.
So can you bring up my presentation there?
Okay, 1 second.
Looks like it's loaded.
Okay. Okay, here we go.
Okay, New Horizons at Pluto, a decade of discovery. Some of you may not know that there was a Pluto mission proposed a number of years before the actual New Horizons mission. I think it was called Pluto Express. And it was felt by Congress and others, I guess, that it was too expensive and somehow didn't quite fit into the NASA planetary science budget. However, the science community argued strongly that we needed one because Pluto has a fairly elliptical orbit, right? And so it gets close to the sun and far from the sun, right? Perihelion, aphelion. And when it gets far from the sun, its atmosphere freezes out onto the surface. And so there was some concern that we may not get there if we delay this mission too much before the atmosphere froze out. Well, there was all kinds of discussion about that. But this resulted in the funding of New Horizons mission. Here's the launch. It launched on an Atlas V rocket on January 19th of 2006. And it reached the Pluto Charon, or I guess it's really Charon. I've heard both, but the Pluto Charon system on closest approach on July 14th of 2015. And then, as many of you know, it went on to intersect a Kuiper Belt object that we now call Arrokoth. And that was on January 1, 2019. And by the way, they had a big New Year's and New Year's Eve celebration at Johns Hopkins Applied Physics Laboratory, and I was there for that. That was quite exciting. So here is the spacecraft. It has two imaging systems: Ralph, the visible and infrared imager and spectrometer, and LORRI. And many of the pictures that I'll be showing you today are from the LORRI camera, the Long Range Reconnaissance Imager. The other instruments, ALICE is a spectrometer, ultraviolet spectrometer, and the others are fields and particles instruments to gauge the solar wind and the environment, magnetic fields perhaps, and that kind of thing around Pluto. Well, I just threw this picture in because just to give you a sense of how large the spacecraft is compared to some of the people in the clean room. It is roughly the size of a, maybe we could say a small minivan, something of that nature.
They always said it was sort of the size of a grand piano, and it's roughly grand piano shaped as well. But you can see that it is actually not far off that, isn't it?
That's half the fun, is finding things to compare it to, like a baby elephant or what have you.
So
An
quite
area
actually,
the size of Wales.
I agree. Okay. So here's the flight path. It had a rather interesting Jupiter encounter. Of course, that was as a gravitational assist, and got some wonderful images of the Jovian system that we can combine then with images that we got from Voyager, from Cassini on its way to Saturn, and of course Galileo. So this provided some really nice data. And then on to Pluto and Arrokoth, and then out of the solar system. So here's just a graphic showing not only the New Horizons mission, which is roughly in the ecliptic, in the plane of the solar system, but also the Voyagers 1 and 2 and Pioneers 11 and 10 missions. Pioneer 10 to Jupiter, Pioneer 11 to Saturn, and then Voyagers 1 and 2 to the gas giants. The question has been asked, why didn't Voyager 1 and Voyager 2 go on to explore the Kuiper Belt? And as we can see from this graphic pretty easily, it's because they exited the solar system at fairly high inclination angles, okay, not into the near the ecliptic. And so that's why they weren't able to do that. I had to get in a little Voyager something here on the.
Of course.
Well, a little historical data. This is Clyde Tombaugh, the discoverer of Pluto. He discovered it at the Lowell Observatory, Flagstaff, Arizona, and he led the naming activity, which resulted in the name of Pluto, and we'll talk about that in just a moment.
That's a lovely photo, Lou, because I think I've only ever seen photos of Tombaugh when he was an old man, so it's nice to see a younger one of him.
Ah, I have a couple others here.
Oh, wonderful.
Here he is at the telescope at Lowell Observatory on the left, and with his homemade telescope on the right. And this is just so cool. He put this homemade telescope together. It's a 23 centimeter reflector, and he made it out of a crankshaft of an old 1910 Buick, and parts that he scoffed from a cream separator. And so I'm sure those weren't the optics, but certainly the hardware. And he put this together himself, and he began his own amateur observing routine. And he observed Jupiter and Saturn and sent those images into the Lowell Observatory. And lo and behold, they hired him. They were looking for someone to staff their new telescope, was imaging telescope, and it was equipped with a camera that could take 2 photographs of the sky on different days. And this is a device known as a blink compactor. And it would you could rapidly flip back and forth between the 2 images to see if anything was moving. Of course, the stars, for that time frame, a day or a week or that kind of time frame, the stars stay fixed. But asteroids and comets and satellites, I suppose, other things move. And so this is how he was able to eventually discover Pluto. And he noticed, and I'll show you a picture of what he noticed here. Here it is. This is an image actually that's set up at the Lowell Observatory on a plaque. This is from the blink comparator. I guess it's not compactor. I guess it's comparator. And if you notice, it's very faint, but the arrows point to a little dot that moved between the 2 images, one taken on the 23rd of January and one on the 29th. And this was, in fact, the discovery of Pluto. And for this, they actually put some of his ashes on board the New Horizons mission. So he, in a way, he got to fly to the planet that he discovered. And by the way, he knew there was controversy over Pluto being a planet before he died. People asked that. Well, let's go back in history just a little bit here. I used to get a Time Life book from my aunt and uncle every Christmas. And this one was called The Planets. And this was for Christmas 1967. And I reference this book more often than I would think. But here, opening it up to pictures from the outer solar system back in 1967, the bottom frame here are two images, the best images that we had at the time. And I believe these were from the Hale reflector, the 200-inch Hale reflector on Mount Palomar. That is Pluto. And that's what we knew of Pluto. Those were the very best images we had. Above it, by the way, are Uranus and Neptune. So this is what ground-based observatories could do back in 1967. March forward a number of years, and we had Hubble. And these are two images of Pluto. The actual images are the small boxes in the top. And then they were expanded and probably, I think, image processed just a little on the bottom. And these are two hemispheres of Pluto. So before New Horizons, this is about as good as we could do to try to understand what the surface, perhaps the atmosphere of Pluto was like. Are these cloud features? Are these surface features? It's very hard to tell. A lot of modeling went into this. And so there were some guesses. But these are the best images that we had before New Horizons. Now, the next image that I'm going to show you is a, let's see here. Here we go. Is a colorized image of that. Understanding what the wavelengths are that are promoting the brightest the brightest signal. And so that's kind of it. There it is. That's Pluto. For almost all of human existence, that's the best we had up until New Horizons. This is an image taken from the New Horizons spacecraft of Pluto on the right and Charon, its moon, on the left. This was a picture from the LORRI, the Long Range Reconnaissance Imager, taken on July 8th, 2015 at a phase angle of about 15 degrees. Phase angle is the angle that you would see between the Earth and the Sun if you stood on the planet. And it makes a difference because it affects the brightness of the image in certain cases. Oh, I just put this in. This is Fran Bagenal, who was on the New Horizons team. Here she's holding up a 3D model that you can print if you have a 3D printer of the New Horizons spacecraft. And I've got the URL for it down here. It's a lot to remember, but all you have to do is Google or your favorite search engine, New Horizons 3D model, and it'll pull it right up. Actually, I think it was a little out of, that slide was a little out of phase, but who cares? Okay. Another image of Pluto and Charon that was taken from the ground before the Pluto encounter. This was taken by the North Telescope at the Gemini Observatory using speckle imaging technique for better clarity. And so they had adaptive optics going here and so on. And this image was released back in 2012. This kind of shows you where we've gone. So Pluto encounter. Here we are. Tons of images of the surface. The surface is amazing. The atmosphere is even more amazing because atmospheres are. You can see on the left hand and the upper left here the various images of Pluto and Charon as the spacecraft drew nearer and nearer. Images of the various features on the surface, which we'll be talking about in just a moment. There are mountain ranges with ice-covered mountain ranges and nitrogen valleys. and an atmosphere that is dominated by a detached haze layer, as you can see in the kind of middle right image. This is taken from behind Pluto, looking toward the sun, so you're seeing the sunlight come through and be scattered by the haze layer. Just a fascinating place.
Wow. Oh, wow.
Here we go. So this is the sharpest image, the highest resolution image of the surface of Pluto. And this image shows a very rugged mountainous region that is dominated by water ice called Al-Idrizi mountain chain. And below it and to the right is the rather smooth nitrogen ice rich valley of the Sputnik Planum. This was taken at about 12,500 kilometers from the surface, darn close. I just think it's a absolute magic that they can thread the needle like that at such distances.
It's amazing.
And this, of course, is just one of many images that was acquired near closest approach.
Am I right in thinking that those mountains are water ice?
Yes, they are. They do appear to be
hard as steel.
At those temperatures.
Yeah.
Less than 50 degrees Kelvin, I believe. You are absolutely right. So another beautiful image of Pluto and Charon from the New Horizons mission. This was taken from just 12,000 miles or 19,000 kilometers out. By the way, that's less than the distance between London and Sydney, Australia. So we're talking pretty close. Charon orbits Pluto with an orbital period of about 6.4 Earth days. But in fact, they orbit each other. The very center of the two of the moon and the planet are outside the surface of Pluto. So it's a double planet system, often referred to that way. And they are both tidally locked to each other, so that Pluto shows the same face to Charon all the time, and Charon shows the same face to Pluto all the time. This is not unusual, by the way, certainly for moons to be tidally locked to their planets, just as our moon is. Let's see. So the rotation rate of Pluto is about 6.4 Earth days, and it's actually a retrograde orbit, so indicative of some violent formation activity. I said orbit, I meant rotation.
Mm-hmm.
So close up of Charon. While it's mostly gray, its northern pole has some reddish tint, as you can see, and a good deal of the moon is covered, as Andy was saying, by water ice. But the red region is possibly made up of pieces of Pluto's atmosphere. In other words, they're close enough gravitationally that they exchange material, and of course Pluto has an atmosphere that can escape and onto the surface of Charon. It has a rather surprisingly young surface, which suggests that it once housed an ocean in its interior, and that there's been some resurfacing going on, and that process has probably long ago frozen out. If we compare this to most of the other solar system planets and moons, the Pluto-Charon system is angled or tipped on its side a bit in relation to the sun. And as I mentioned, the orbit of Pluto is retrograde here, so it spins backward from east to west. Pluto does have other moons, much smaller than Charon, likely trapped asteroids, some of them possibly displaying features of collisions in their past. So these are Styx, Nix, Kerberos, and Hydra, all of them kind of Greek figures from the underworld. this image is really quite striking. This shows the atmosphere with the detached haze layer in really high contrast. It's a panoramic image taken by the LORRI camera. It shows the mountains and the plains in rather high detail. The sun is backlighting these features, so it's coming through and scattering through the atmosphere and through the atmospheric haze, showing its layered composition. Very similar, by the way, to Titan, which also has a detached haze layer. And this is all happening inside a largely nitrogen N2 atmosphere. So when you see these things, you start to put models together that can match the thermal properties and the spectroscopic properties of the observations that you're making. Here we see a number of thermal profiles. There's altitude on the left and temperature on the bottom, showing some options, I guess I'll say, for a turnover in the atmosphere, troposphere, and the stratosphere in Pluto's atmosphere. The atmosphere of Pluto, as I said, is mostly nitrogen, N2, with minor amounts of methane and carbon monoxide. These gases are vaporized or actually sublimed, right? Going from a solid to a gas from the surface ices into Pluto's atmosphere annually, at least Pluto's annually. Pluto's atmosphere contains this layered haze layer that we can see so nicely as the sunlight is scattered here in this image, in the previous image. And these, no doubt, consist of heavier compounds which form from the gases and the various photolysis that goes on from the high energy radiation. Nevertheless, Pluto's atmosphere is thin. It's not like Earth's atmosphere or Titan's atmosphere or the gas giants. Very thin and very tenuous. And as we said, it expands when it comes closer to the sun, and it collapses when you get further away from the sun. And so it gradually freezes out and falls onto the surface. The images that you see here, the black curve, the black temperature curve here is the observations made by New Horizons. The blue curve is what we thought the atmosphere might look like as a function of height before encounter. The yellow curve, or kind of yellow-orange curve here, is the modeling that was done using gas only, with no atmospheric haze and no water. And then when we add in the gas, when we add in the atmospheric haze, we get the red curve, which does a very nice job of modeling the thermal profile of Pluto. So that's my last slide. We have tons more to say about Pluto, the Pluto-Charon system, and the New Horizons mission. And as we get closer and closer to the actual date of 10 years since Pluto encounter, we'll be talking about Pluto more and more, and hopefully we'll get some of your questions as well. So I'll end there. Yay.
Thanks, Lou.
Thank you, Lou.
Are there any questions from our audience or our panel?
I have a question, Lou.
Mm-hmm.
So we talk about tidal locking. Is there a formulaic way to work that out? In relation to
you can model the forces. It's a two-body system, right?
Yeah.
If we take the Earth as an example, you have the moon pulling on the Earth, solid Earth, as well as the liquid Earth, the oceans, and it creates a bulge on both sides of the Earth, which act as kind of handles to pull the moon around. And as that happens, the orbital period of the moon and the rotational periods of the moon change over time, and you can model these forces, fairly easily, I think.
Okay, and is it dependent on the smaller of the moons being smaller, or is there ever an occasion when that two-body system, they can both be the same size and they would still be tidally locked?
If you had a planet and a moon that were the same size and mass,
Yeah.
I don't see why not. Of course, all the example. So here we have Pluto Charon. They're both tidally locked to each other, right?
Yeah. Yeah.
Pluto is more massive, but it's tidally locked to Charon, and Charon is tidally locked to Pluto. So I think the answer there is yes.
Yeah. Thank you.
Yes, and viewers, if you have any questions for Lou about that, then don't hesitate to put them in the chat. As Lou said, we'll be featuring more about Pluto as we get near the 10th anniversary in July. As Lou said, there's so much to say about what was discovered at Pluto, and it's going to be many years before all the data is completely sifted through and analyzed. And obviously, the great tragedy is that we don't have another mission planned to Pluto in the foreseeable future. So New Horizons bounty of data is all we're going to get for decades, which is very sad. There should have been a follow-up mission, because I think once we realized just what an interesting world Pluto is and really worthy of further study, then there should have been another mission planned to carry on the good work. And of course, the time delay between missions, especially going to the outer solar system, is such that when another spacecraft follows it up, the technology is always years and years better. It's very sad, really, that those images from New Horizons are all we're going to get from Pluto, certainly in my lifetime.
That is absolutely true. However, one of the things you can't do with a flyby mission that you can do from, say, Earth orbit is to observe the planet over long baselines. And while we cannot get the kind of the cool, exciting spatial resolution of the pictures that I just showed you, we can get spectra, and we can now identify features that are rotating the planet. We can do modeling to get more information about the atmosphere, the atmospheric dynamics, how the atmosphere changes with Pluto's seasons over time. So there is data we can get. It's just not going to be the exciting images, as you point out, Andy.
And of course, if you want to send a spacecraft there, you want to get it there really as quickly as possible. So if you wanted to put something into orbit around Pluto and still get it there fairly quickly, it would have to be going so fast that it would become impossible for it to slow down to get into orbit around Pluto without carrying a whole lot of extra fuel. So it's a bit of a shame, really. And this is why we should have a base in the outer solar system somewhere for launching these vehicles on a regular basis. But one can dream. Maybe one day. But thank you ever so much for that, Lou. We'll let you get off to your teaching now, as I'm sure you're about to do. We'd like to thank your student for being here as well.
Yes, well, hopefully others will join as we move on in the semester.
Yeah, and don't forget,
if I give them extra credit, they will join.
Oh, do you? Oh, fantastic.
That's how we get more viewers. We give everyone extra credit.
Yeah. And if you want to, coerce them into maybe donating, $100 a month, then they might even get a free space on the t-shirt. So it's got to be.
I think $100 a month is about the going rate for a 1 grade boost. Sounds about right. Don't you think?
Makes sense. Yeah. Makes sense.
Roger is shaking his head and not.
Yeah. Can I just answer Anne's question? What's the next destination for New Horizons after Ultima Thule? Ultima Thule was the original name of the Kuiper Belt object that New Horizons passed.
Arrokoth.
Yeah, and it's now called Arrokoth because Ultima Thule had Nazi connotations, so they quickly changed the name of that when they realized. And the answer is there aren't any. Astronomers are still looking for Kuiper Belt objects that may lay in the path of New Horizons, or at least they may be able to divert New Horizons to with the amount of fuel that it's got. But for the foreseeable future, we're not likely to see it visiting any other body because there's just nothing else in the way. But the hunt is still on for another body that New Horizons could visit on its trip through the Kuiper Belt. And in fact, I think it exits the Kuiper Belt fairly soon, doesn't it, Lou? I think it's
the Kuiper Belt seems to be fairly well defined if we can take the limits on the orbit, small period orbit of comets that we see. So it should exit fairly soon. It should be moving somewhat, about as fast as Voyager. I would think about 3 AU per year, something like that.
Yeah. I think I read somewhere it was going to exit within the next 2 years out of the Kuiper Belt. I have to check that. If anybody knows when New Horizons is going to exit the Kuiper Belt, please put it in the chat.
I should mention that I believe the funding for New Horizons ongoing mission operations has been transferred to the Heliophysics Division at NASA headquarters, I think. And if that's the case, then although it will not be encountering any new Kuiper Belt objects, it will continue to send back fields and particle data of the outer solar system, which is also valuable.
Didn't I read somewhere that it was transferred back, though, after an outcry? I'm sure I read that somewhere.
Oh, really?
Yeah. Yeah, but we can check that out. But I'm sure I read that so many people have protested about New Horizons being relegated to basically a solar observer that they put it back again. I may be wrong.
There's nothing else out there.
Perhaps I dreamed it, which is a bit worrying in itself. So there we are. All right then, Lou. Thank you for that. We will see you next week. And
thanks, everyone.
Have a great week, Lou. And we will see you soon.
Same to you. Take care, all.
You too.
Bye,
Lou. Bye.
Hi, Lou.
So moving on, we're going to move over to the news, and there hasn't been that much in the news this week. Been a lot of stuff about the upcoming moon missions. We'll talk about that a little later, but so there you are. There we are. I was right, Michael. Michael says, well, you can read it, Michael.
Yep. NASA has announced it is to extend operations for New Horizons until the spacecraft exits the Kuiper Belt, which is expected to occur between 2028 and 2029.
That's right. I was right. I said about 2 years.
There you go.
Yeah. So they're going to fund it as a planetary mission until at least then.
Yeah.
So that's good news. Thank you, Michael.
No problem.
And it's a wonderful spacecraft, and it should stay as a planetary observer. And let's hope astronomers can find another destination for it. We will see. Okay, let's move on with the news then. As I said, not much going on in the news this week. Just got 2 items for you this week that I thought you might be interested in. So just give me 1 second, and we will get the news up, as it were. So the 2 items this week are, funnily enough, they are both about black holes. So let's just get rid of our ugly mugs off the bottom of the screen, and we will go to this. Okay, so the first item is a bit of a big one in terms of the study of black holes. Astronomers have found a big haul of intermediate mass black holes. Now, I want to set the scene for this so that you appreciate what a great discovery this is. So astronomers know of 2 types of black hole, and these are them. We have the stellar mass black holes. They're called stellar mass because they basically form from collapsing stars, not because they have the mass of the sun, but they are formed from collapsing stars in supernova explosions. And they have a range of masses of between about 5 and around 100 solar masses. And on the right-hand side, we've got the really big beasts that we find at the center of galaxies. Most galaxies, not all, but most galaxies have a supermassive black hole at their centers. And these masses can be measured in millions up to billions of solar masses. So we know of these 2 distinct populations of black holes, but there is another one in the middle, which are called intermediate mass black holes. And they would range from the upper limit of stellar mass black holes up to Well, we don't know. Do they go right up to supermassive black hole mass, or what happens? Well, I think astronomers are coming around to the idea that what happens is you start with stellar mass black holes. They then merge to form intermediate mass black holes with twice, or actually not twice, but nearly twice the mass of the two black holes that merged. And then they go to merge with other intermediate black holes, intermediate mass black holes, and then they merge in turn. And eventually you sort of have a hierarchy of masses all the way up to supermassive black holes. The problem is that we haven't really found any of these intermediate mass black holes. The population seems to be elusive. We know that they must be there, because to have nothing between 100 solar masses and maybe millions of solar masses for supermassive black holes doesn't really make any sense. So astronomers have always believed that there would be these intermediate mass black holes. A few candidates have been proposed, but nothing definite. Well, the good news is that we now have this missing population. And astronomers have discovered a literal treasure trove of feeding black holes at the heart of dwarf galaxies. So they surveyed, I think, about 300 dwarf galaxies. These are little galaxies with, thousands of stars to, a few billion stars, but very little gas. And they've done a big survey of these. And on the right-hand side, those galaxies are now thought to contain these intermediate mass black holes, obviously to be followed up on. These were made with the discovery was made with the Dark Energy Spectroscopic Instrument, or DESI. And these are the ones that are suspected of having intermediate mass black holes. Now, how do we know that they're there? Well, very simply, when a black hole starts feeding on the material that surrounds it, it releases a lot of energy, mostly in the form of X-rays. X-rays you get when things are really hot. And so these X-rays can be detected, and this is exactly what they've done with these dwarf galaxies. And by measuring the amount of X-rays that are being released, you can sort of work out them and where the X-rays are and how fast they're moving and everything else. You can work out the mass of the black holes around which it's producing the X-rays. And apparently these all are intermediate mass black holes. That is to say, black holes with mass greater than 100 solar masses. They've got to work out the exact masses yet, but all of these are strongly suspected of containing these intermediate mass black holes. So this population of intermediate black holes is like the missing link, if you like, between stellar mass black holes and supermassive black holes. And now we have some highly probable examples of this population. But it raises some other questions, because the team that discovered this, actually, they never satisfied astronomers. They actually expected to discover more of these intermediate mass black holes than they actually did in the survey. So that's raised another question. And another question is that you seem to get different types of black holes depending on what type of galaxy you're looking at as well. So there's some sort of link between the nature of a galaxy and the mass of the black hole. And that is an intriguing question on its own. There's so much we still don't know about black holes. There's a lot we do, but there's so much we still don't know about black holes, in particular the dynamics between black holes and galaxies, because it's only fairly recently, only about the last 10, 15 years, that we've begun to realize how much a black hole influences the evolution of the galaxy that it sits in. So this is very exciting news that we may have found this missing link population, and they're hiding in dwarf galaxies. But why dwarf galaxies and not elsewhere? Interesting questions that obviously are going to be followed up. So that's the first story. So moving on to the next one. This is another black hole story, but this one is about the black hole at the center of our galaxy, Sagittarius A star, as it's called, which has a mass of 4 million solar masses. So as supermassive black holes go, a bit of a lightweight. However, this is our local supermassive black hole. And the James Webb Space Telescope has been looking at it, and the team got observing time for 8 hours a day for a whole year to observe the black hole at the center of our galaxy, obviously in the infrared. Now, there is a disk of material around our local supermassive black hole. When I say local, it's 26,000 light years away, so not down the road, but it's local to us. And what they've observed, whereas we thought that the Sagittarius A star was quiescent, that there was very little activity going on, what they've observed with the James Webb is that they're observing flares coming out of the disk, the accretion disk around Sagittarius A star 5 or 6 times a day. And these are very bright flares. They can only really spot them with long observations, with a lot of observing time and comparing the images. But it turns out that these flares are originating very close to the black hole itself in the disk. And they are thought to be like solar flares on the sun, where you get magnetic field lines reconnecting. Now, magnetic field lines, it works exactly the same as on our sun and probably every other star. You get a magnetic field, and the magnetic field line gets stretched and twisted, and eventually, like something physical, they actually snap. And when they snap, they release copious quantities of energy. This is what causes solar flares on our star. And we're now detecting them in the accretion disk around our local supermassive black hole. So it's not quite as quiescent as astronomers thought. So anyway, this is quite a lovely discovery, because we can get to learn an awful lot about black hole dynamics from studying things like this. And obviously more observations are planned to try and learn more. So this is a great story as well. Black hole science is moving on so fast, and there are almost certainly some major revelations to come in our knowledge of black holes. So there you are. So that's the news for this week, and I'll keep you posted if there are any updates on either of those stories, obviously. But there we are. So that's the news for this week. What we're going to do now is we're going to go over to Roger, and Roger's going to deliver us his wonderful guide to the night sky and the gallery. And thank you, folks, because we've had a few more gallery entries in this week than we had last week. So, Roger, what's going on this week then?
Oh, well, apart from it being clear skies tonight and we're inside, but there we are. That's typical. Okay, so we're working our way through the latter part of February and into the start of March. So here we go. Right, we've currently got a very waning moon, which we will be getting a new one on over Thursday and Friday. So that might help any viewers, but it's not currently getting up very high in the sky anyway. So that's all well and good anyway. And of course, we've still got the winter constellations up in the night sky, although they are now starting to head towards the western horizon. And if people have been seeing the local news, we've got the planetary parade over the next few days, which is now enabling Mercury to be added to the collection as well. So although you will need to be very careful looking quite shortly after sunset to be able to find Mercury, but apparently it will be visible for a few days in the meanwhile. So we've still got Jupiter, Mars and Venus earlier on to view, and looking quite spectacular at the moment. So all being well. Of course, we're now starting to get Leo up, and also Virgo, so it'll be galaxy season soon. And also people that might be interested in the Messier Marathon.
Oh,
so,
yes.
So that can all happen quite well. This is just before sunset. Obviously, the sky isn't naturally visible like this, although it would be nice to be able to. But we don't live on the moon or anything like that without an atmosphere. But as you can see, we've got Saturn and Mercury fairly close together, low to the horizon. So that could be a bit of a challenge if you don't know where to look and you have got a clear horizon, then you might have a chance, but be careful. It's still fairly close to the sun, so be aware of that. And then further on, we've got Neptune, which will be only visible after sunset and quite low down, but you will need a telescope to have a chance of seeing it. And then, of course, without any optical aid, you've got the brilliant shining Venus up high in the sky. So things are looking quite good there. But as you can see, Mercury is moving rapidly up into the up above the horizon. So there is a good opportunity for people who haven't actually seen Mercury to get this opportunity this week, providing you've got clear skies. Good luck with that. Okay, so we do have a few entries for this week's gallery, and our first entry is from Graham, and he says ahead of Moon Month, woohoo, he went to the Science Museum and he was having a look at the Apollo 10 command module, and he was quite impressed with that. So he's looking forward to seeing Charlie Brown being exhibited a bit better, because it was a bit of a problem with all the people going to look at this historic craft. And as you can see here,
Oh, lovely.
quite an interesting view of the craft. He's obviously just got it at an angle, so there aren't any people in the way to block the craft. But yeah,
Wow.
so that is so that would be early 1969, wouldn't it?
Yes.
If it was Apollo 10, so probably
Yes.
a February or so, 69 to do that. But
Mike will be able to tell you, I'm sure.
yes, I'm sure he would. But it's nice to see an actual piece of the Apollo mission in person.
It would.
Okay, so Jerry Delay, another one of our very regular contributors, has got M78 in Orion with his usual setup. So he's got 2.5 hours of exposures all put together in pics in sight, and this is what he managed to achieve. Got some nice details there.
Beautiful, Jerry.
And that lovely blue gas there, all
nice.
illuminated. All those stars being created in that, and all the other filaments and stars in that area as well. Well done. Lovely. Okay, now one we got from Dave Garside. So the Tadpole Nebula. He had a slight problem. He deleted half of his integration.
Oh,
no.
Been there.
There we go.
You don't want to do that again.
Here's the result of what he managed to get with just an hour and a half.
Oh wow!
So he's done quite well considering even with that. So
Just an hour
well
and a
done,
half.
Dave. Yeah, still hour and a half, but yeah, never mind. But yeah, still
it's
worth.
still pretty damn. It's better than anything I could do. Let's put it like that. So well done, Dave.
Yeah, got some nice details there. Well done, Dave.
Lovely, thank you.
And we've got a couple of interesting images from Ian McIntyre.
Oh,
Hello, Ian.
Yeah. And we've got some rainbow shots here. It was done just a day or so ago. I don't know if you can
there is a rainbow.
You can see it. There is a rainbow over the house.
Yes.
Yes.
I can see a rainbow. Sorry.
Right now.
And this is the other one that he produced. That first one was in the morning, and this one was in the afternoon.
Oh wow!
And this one was a bit more striking because obviously the lower angle of the sun was giving it a better contrast, giving it a bit more definition there.
That's beautiful, Ian. Lovely.
Very nice.
Lovely.
So that's what we have for this week's What's in the Night Sky and our gallery.
Thank you.
So keep sending those images in.
Yes, yes. Don't forget, if you want to contribute to the gallery, we would love to have your entries, and you can mail them to gallery at spaceoddities.space. Hang on, I'll just put up the address there on the screen for you. Gallery at spaceoddities.space. Anything to do with the sky, we're interested in. So,
and it doesn't have to be over the last week. It can be,
no, it can be
a year or 5 years ago.
Yeah,
we don't mind.
Any image that you've taken of the sky at whatever time in your life, we'd love to see them. On the other hand, if you want to send us photos of your cats, don't bother. We're not.
My cats are called Apollo and Saturn, so don't matter.
You're out, Michael.
Yeah, very, very, very sad.
Mine's called Jonesy from Alien.
Oh, well done.
Although it was actually Mr. Jones.
Right.
We call him Jonesy.
No, not Bridget then.
I don't.
Yeah, and we have 4 cats, and their names are boring, so I'm not going to tell you. But there we are. So yes, so send in your gallery entries to gallery@spaceoddities.space, 1 per email, please. If you could attach them to the email rather than paste them into the email, that will make our life a lot easier, or specifically Roger's life a lot easier. So as he looks after the gallery. So if you could do that, that'd be great. And if you could try and stick to a maximum resolution of 1920 by 1080, because anything else, frankly, is wasted because it'll have to be shrunk down to fit on the screen. So excuse me 1 second. So yes, if you could just do that and then send the email to gallery@spaceoddities.space. Then we'd love to see them. And as we always say, you don't have to use expensive equipment to take your images. Even if it's with a smartphone, we'd love to see them. With a box brownie or a pinhole camera or a camera obscura even, then we'd love to see your images. We're not we're not sniffy about equipment at all. We just love images however they're taken on whatever equipment.
And
so
smartphones are very good at taking images these days.
Yeah, absolutely. So anything you've got, please send them to us. And thank you very much. Of course, you also get the image to appear not only on this Tuesday live stream, but on your own little gallery on our website. So that's got to be worth doing, having your own gallery on the website. And speaking of gallery type things, don't forget that Tom has developed a wonderful app called Picastro, which is, if you like, it's like the Instagram for space nerds is how he describes it. And that is a sort of a social media for people to post their space images uncompressed and share them with others. And the app is called Picastro. You can download it free from the Apple Store or from the Google Store. And if you want to know more, you can have a look at the website at picastroapp.com. And it's a wonderful app for astrophotographers to get together, share their images, and not have to suffer idiots. Yeah, well, it's true, isn't it? Because Tom is trying to build a community of like-minded people who police the social media and keep it free from flat earthers and moon hoax deniers and conspiracy theories of. Yeah, I know.
Flat earthers.
Yeah. So
they've got members all around the globe, don't you?
Yeah, absolutely. Yes. We had one pop up here in the chat earlier. I don't know whether you saw it. It's saying all of space is fake. Filmed in a Hollywood basement. All of space, everything.
Okay.
So I'm afraid we had to give him the order of the boot rather quickly. So,
Okay.
I've had people message me to say that NASA puts images in my mirror.
Sorry?
Yep. I genuinely don't. NASA puts images in my inanimate mirror.
Right.
Okay.
Go figure.
Well, I can't even.
I have no answer for that either.
It's crazy.
Oh my goodness.
Yes. Anyway, from apparitions and mirrors, ghosts, in particular, Blue Ghost.
Hey.
Yeah, that's a rather nice segue.
Nice segue there.
Yeah. There we are. Okay. So the Blue Ghost lander, which launched a couple of weeks moonwards, is actually in orbit around the moon now. Michael's going to tell us a little bit about it, and it's due to be landing on March the 2nd. We will be covering that landing live on Space Oddities. Before we do that, though, it's been beaming back some lovely still images of the moon that it's flying over, which have been edited into a video, and here it is. So this is the moon that Blue Ghost has been flying over, and I think it's an amazing video, as you'll agree. I mean, look at that. It's just absolutely, you can really imagine yourself there, can't you?
Yeah.
Absolutely stunning. So Blue Ghost is an interesting mission. It's the first of 2 landers. Well, in fact, the first of 3 landers that are going to the moon. And Blue Ghost is from a company called Firefly, who've been really up and coming in space over the last few years. So I'm going to let Michael now tell you all about it. So Michael, tell us a little bit about Blue Ghost then.
Okay. Right, here we go. So this is a short presentation about Blue Ghost. Yeah, this is the Blue Ghost Lunar Lander Mission 1, otherwise known as Ghost Riders in the Sky. There's an image of the lander there. Going to go into more detail about that shortly. Okay, what's in the name? Firefly Aerospace has designated the name Blue Ghost 1 for this mission, marking the initial flight of this planned series. Blue Ghost is a unique species of firefly that inhabits the southeastern part of the United States. They are soft-bodied beetles, commonly called fireflies, lightning bugs, glowworms. Oops, I don't know what's happened there. Hang on. I think something's going wrong here, and just bear with me. That's going too fast, Andy. What's happened? Hang on. I'm going to start that again. Oh, dear me. Sorry about that. I don't know what's happened there. I was supposed to control that, and it was going on its own.
Oh. It's NASA. Blame NASA.
Yeah. Just bear with me. Oh, I think I know why. Oh, no, it's done it again. Whoops.
Sorry, do you have a problem?
Yeah, I do actually. The slides seem to be going on their own rather than me changing them.
Oh, that's interesting.
I know. So this is the lander, Blue Ghost, otherwise known.
It's Michael. You're going to have to reshare your screen.
Of course I am. Oh, sugar! I hate it when this happens. Okay.
Apologies, viewers. Just 1 second while this gets right.
Okay. Right. So yeah. So this is the Blue Ghost Lunar Lander Mission 1, otherwise known as Ghost Riders in the Sky. So I was doing it again. Right.
Right. Should we come back to you?
Yeah. Can you come back to me because this is going silly? Sorry about this, folks. I think I know what's happened. I should be able to correct it. Okay, yeah. Can you come back to me in a short while? Have we got anything else? Just bear with me. Right. I think. Yeah. Really sorry about this, folks. No, it's still doing it. Sorry, guys.
Do you have a stuck key, Michael? Maybe is that what's causing it?
Right, I can start again. Yeah, I think I know what's happening. Can you see my slides?
No.
Okay. Right, let's try again.
That's it. That's it.
Yep. Okay, so, this is the Blue Ghost Lunar Lander Mission 1, otherwise known as Ghost Riders in the Sky. That's an image rendering of the Blue Ghost lander itself, built by Firefly Aerospace. So, what's in the name? Firefly Aerospace has designated the name Blue Ghost 1 for this mission, marking the initial flight of this planned series of, I believe, 3 missions. The Blue Ghost is a unique species of firefly that inhabits the southeastern part of the United States. They are soft-bodied beetles, commonly called fireflies or lightning bugs, etc. Known for their conspicuous production of light, mainly during twilight, to attract mates. I was doing it again. I'm sorry, guys. I don't know what's happened. I'm going to have to. Really sorry about that. That's gonna. It's on. Yeah, Ian says I'm on automatic play, and I am, and I don't know why, because it didn't set it at that. Oh, sorry. Well, where's Andy gone?
We've lost Andy.
We've lost Andy. Should we go to you, Roger, next then, with your constellation?
I need Andy to put my presentation up. Whoops.
We've lost Andy.
Oh dear.
There. Ooh.
Oh.
No.
Oh, there
Aha.
we go.
Oh, there we are.
Are we?
Right. Okay. We'll do the constellation of the week, which is Gemini. Da, da, da. Right. Okay. So Gemini. There we are. Everyone knows the 2 lead stars, Alpha, Beta, which is Castor and Pollux. And we will go through some of the stars and some of the objects in this constellation of the twins. Okay, so Alpha Gemini, known as Castor, is a multiple star. So Castor A and Castor B are plus 1.9 and plus 3 in magnitude. And it was first sort of seen in the 60s. It was only 1.8 arc seconds apart, but they are now widening up a bit. So they do orbit every 45 years, but that's for what we've got on that one. So as we move on to that, so Pollux is a magnitude plus 1.16 orange giant supergiant and 34 light years away. It's also believed to have been a blue-white A-type main sequence star. And obviously, since it's exhausted the hydrogen, it's now an orange giant that we see today. Okay. Then we go down to Alhena, which is Gamma, and that's a hot blue-white type A1 star, and that's 109 light years away. We then go on to another double star, which can be interesting if you've got a large enough scope to try and do the separation. It's only 5.8 arc second separation, and there are magnitude 3.6 and 8.2. So interesting idea to see if you can visibly separate that with a decent sized scope. So there's a challenge for you if you're into double stars, which can be quite interesting. Okay, so we then go on to Mebsuta. So that's a wide double star as well. So we've got quite a few double stars in Gemini. So it's interesting to see how you can deal with this. Although it's a 3.1 and a 9.7, it's very widely separated by 111 arc seconds, so not too bad. And as it says here, the star achieved much publicity on the 8th of April 1976 when it was occulted by Mars, allowing measurements of the planet's atmosphere to be made. So that was an interesting thing to happen.
Mm.
Not a lot of people know that, said Michael Caine.
Very good.
Okay, so we're then going on to Mu Geminorum, the fourth brightest star in Gemini, although it has another double star companion of a magnitude 9.4, and it's a deep red in color, although it is a very wide 122 second arc separation, so not too difficult to see, but magnitude 9.4 is a little bit faint if you haven't got a decent size aperture on your telescope, so all's well and good. Okay, so we're then going to go on to some of the other interesting objects in that constellation, and obviously the first one we've got here is M35, and that's a big open cluster, magnitude 5.2, and it's quite interesting to see just using binoculars. So that's about 200 stars located 15 arc minutes, and we've got another little object there which is NGC 2158, which is in this picture as well, so have a look at those if you wish, if you haven't already. Okay, and this one's a bit more interesting. This is known as the Eskimo Nebula. It's 48 arc seconds across, so it's about the same size as Jupiter. This is obviously a Hubble image, which is why it's so well defined on the picture there, and it's this was taken in January 2000, so it's about 2,900 light years away, and does show quite some interesting features from what's happened in its history. Okay, right. Now this one, I think, looks a bit like a sweet wrapper.
It does.
And this is NGC 2371-2372, which is further in between Castor and Pollux. I've never seen this before, but they say its structure is reminiscent of the Dumbbell Nebula. And there we are. So it is a 30 magnitude 13, so it's a little bit on the faint side, so you obviously need quite a lot of time to get any astrophotography on this image, and obviously the results will be worth it, but
yeah,
one to keep an eye on.
It does look like a sweet wrapper, if I remember them correctly.
Yes, it does, yeah. Okay, and we've got the Medusa Nebula, Abell 21, which is on the periphery of the borders of Gemini. Another little interesting object. It was only discovered in 1955 by astronomer George Abell, who originally classified it as an old planetary nebula. It's also got a designation of sharpless 274. And it's estimated to be 1,500 light years from the Earth. You will need at least an 8-inch scope and hopefully an O3 filter to get any decent definition of this object. So bear that in mind. Okay. And that's all I have for you there. That's the highlight of the stars and the objects for Gemini, this week's constellation of the week.
That was brilliant, Roger. Thank you.
Okay.
Right. Looks like we've still lost Andy. So.
Oh dear.
Oh dear.
we need to unshare my screen.
Okay. How do I do that then?
Oh, I don't know. The same way you got me on.
Just hold on a second. Emit that. How's that then?
Aha.
Aha.
Right. Oh dear.
I have control.
Oh.
I've imaged Medusa Nebula. It's really hard. It's a mag 15, yeah. I think, mag 14, 15.
Yeah.
It's really, really pretty if you manage to get some of the oxygen shell around
yeah.
the
So you need a lot of time with a large scope.
Yeah.
Right.
Yeah.
Yes. Okay. Right then. Shall we go to
Wow.
back to my presentation?
If you're sure that it's going to work, 5th time lucky.
Fifth time. Okay. Right.
Oh,
The trials of live streaming, eh?
yeah, absolutely.
A ship without a pilot. Thank
Yeah.
you.
Never work with children or animals. Right, here we go with the Blue Ghost Lunar Lander Mission 1. As it says, they're also known as Ghost Riders in the Sky for this first mission. And that's a representation of the lander itself on the surface of the moon, landing there on the 2nd of March, as Andy said earlier. Okay, so what's in the name? So why have they called it Blue Ghost? Firefly is the company that built Blue Ghost, and so they have chosen the name from a particular firefly, which is an insect. And this is Blue Ghost Mission 1. This is Blue Ghost 1, the first mission in a planned series of 3 missions for this particular spacecraft, or versions of this spacecraft. So that's the name. And the Blue Ghost is a unique species of firefly that inhabits the southeastern parts of the United States. They are soft-bodied beetles, commonly called fireflies, lightning bugs, or glowworms, for their conspicuous production of light, mainly during twilight, to attract mates. This is a close-up image, macro image of the firefly itself, the said insect, and this is how they appear in the forest in twilight, with a nice glow, yellow glow of light coming from them. So I've never seen that myself. I'd love to see that at some point, but this is what they look like in the forest. Okay. So Firefly Aerospace's Blue Ghost lander is flying missions to the moon with payload services customized to the technology and exploration goals of each customer. Offering rideshare opportunities and dedicated missions, Blue Ghost can deliver and host payloads anywhere on the lunar surface. When paired with Firefly's launch and orbital services, Blue Ghost supports end-to-end CIS lunar services from the Earth to the Moon and beyond. Okay, here's a bit overview of the mission, the first mission. The Blue Ghost Mission 1 will deliver 10 science and technology instruments to the lunar surface as part of NASA's commercial lunar payload services, or CLIPS initiative. It was launched on the 15th of January on board a Falcon 9 rocket, and took approximately 45 days to reach the moon, allowing ample time to conduct health checks on each subsystem and begin a payload science. Blue Ghost is set to land on Mare Crisium on the 2nd of March and operate payloads for a complete lunar day, at about 14 Earth days. There is Mare Crisium on the top right of the moon as you look at it in the sky. I'm not sure what missions have landed there before. I don't think any missions have landed there before Blue Ghost, but we'll check that out. Okay, so this is a breakdown of the different items on the lander. So you have one expand antenna, we've got 3 solar panels, you've got 6 carbon fiber tanks containing 1,000 kilograms of propellant, and 4 shock absorbing legs, 1 main engine, the 3 S-band antennas, 49 carbon fiber struts, 12 ACS thrusters, RCS thrusted reaction control system thrusters, and 2 vision navigation cameras. This was the flight Blue Ghost 1 took to the moon, initially taking a few orbits of the Earth before the lunar transit, then slowly reducing the orbit from the moon until the orbit that it is now, where we saw that nice video that Andy showed earlier. So, okay, this is the landing sequence: braking burn, pitch over, hazard detection, convergence over landing ellipse, landing site selected, final hazard avoidance, and shutdown of the main engine on lunar contact. Okay, on the 14th of March, Blue Ghost expects to have captured a high-definition imagery of a total eclipse when the Earth blocks out the sun above the moon's horizon. Blue Ghost will then capture the lunar sunset on the 16th of March, providing data on how lunar dust leviates due to solar influences and creates a lunar horizon glow, first documented by astronaut Eugene Cernan on Apollo 17 in 1972. Following sunset, Blue Ghost will operate for several hours into the lunar night. Payloads on Blue Ghost will help advanced lunar research and conduct several first-of-its-kind demonstrations, including testing regolith sample collection, global navigation satellite system abilities, radiation tolerant computing, and lunar dust mitigation. These investigations will pave the way for humanity's return to the moon. The data captured will also benefit humans on Earth by providing insights on how space weather and other cosmic forces impact Earth, among other valuable research. So just a little bit about the company to finish off. As an end-to-end responsive space company, Firefly Aerospace is on a mission to enable our world to launch, land, and operate in space anywhere, anytime. Our small to medium launch vehicles, lunar landers, and orbital vehicles allow us to service the entire life cycle of government and commercial missions from low Earth orbit to the moon and beyond. Firefly utilized carbon composite structures, patented propulsion technologies, and common components across our vehicles to iterate quickly, improve reliability, and deliver payloads at lower costs. And that's about it from me. So thank you for that.
Great, thank you, Michael.
Okay. Stop sharing.
Yeah, very interesting mission. Coming up from Firefly with Blue Ghost. As we know, it's established itself in lunar orbit, sending back those wonderful images from the moon. Apologies, viewers, I had to drop out for a few minutes because my camera just decided to turn itself off and not come back on again. But in time-honored tradition, I've turned it off and turned it back on again, and it's fine. So what we'll do now, I'll just tell you about the other mission that we're going to be covering live on SpaceOddities, the launch of the IM-2 lander from Intuitive Machines. Now, you may remember that Intuitive Machines had one previous crack at landing on the moon with a previous lander, which, funnily enough, is called IM-1. Unfortunately, although they had a perfect landing on the moon, the lander then tipped over on its side. So the mission really couldn't proceed. So many of the payloads that we've got on IM-2 are the same as for IM-1. They're going to have another crack, but with some new payloads as well. Now, this is being launched under the auspices of the NASA CLPS initiative. That stands for Commercial Lunar Payload Services. And the idea behind the CLPS was that private companies could launch their own payloads to the moon under the umbrella of the NASA CLPS. And it's a great way for companies to put stuff on the moon. And indeed, many of them are. And there are quite some interesting payloads that I'm going to talk about. But before we do that, let's just have a look at the lander itself, which is codenamed Athena. And if you want to see what the lander actually looks like, this was it before it launched. So let's have a look. So it stands, a good few meters high. This is the drill that will drill down into the surface and take samples from underneath the lunar regolith. And it's expected, or I hoped that we're going to get lots of information about what the moon's surface looks like going downwards. And we can also see on the side there the name Columbia. Now, Columbia is a brand of sportswear in the United States. You may have heard of them. And what they have done is they have created a material to be used as a sun shield for the lander to stop the full heat of the sun bearing down on the lander too much. And it's a new type of material that they hope to incorporate into sportswear. So this is going to be a real test of it. And let's see whether that actually works. And as well as that, I've got another video to show you about the actual mission profile. There's a lovely animation of the mission, which picks up just after it's separated from the Falcon 9 rocket. So there you are. So that's what the mission, hopefully, if all goes well, will actually look like. And thank you to Intuitive Machines for both of those videos. And what I'd like to do now is to tell you a little bit about the payloads, because there are quite a few payloads. Now, the payloads break down into two classes. There are actual NASA payloads that NASA are sending, and then there are the commercial payloads. So just give me 1 second, and we will have a look at both of those. I'm not going to spend too much time on this. I'm going to go through these fairly quickly, because I don't want to bore you with endless facts and figures. But just to give you an idea of what's actually heading to the moon this Thursday, we will have a look at first of all the NASA payloads, and let's just have a look at this. So let's just move us out of the way. So the first category of payloads, the NASA payloads. The first one, hang on, I'll get my mouse working. So there's the ice mining experiment. Now, IM-2 is set to touch down at the south, towards the south pole of the moon, not that far from the lunar south pole. And the thing about this is that, as I said, just one second, I seem to be having the same problem as Michael at the moment. This is interesting.
Oh, yeah.
Okay, let's just, right, here we are. So this is called PRIME, the polar resort. Sorry.
Sugar.
Yeah, it's okay. It's all right. I've got it under control. We appear to be having technical glitches with our presentations, and it's gone. Right, okay, just give me 1 second. Just let me reload this. Don't forget that we know that there is a lot of water ice locked up in craters at the south pole of the moon. And these are places, believe it or not, on the moon where the sun never shines and hasn't potentially for billions of years. So this ice has remained pristine for perhaps, you know, a couple of billion years. And that is why so many countries are heading towards the south pole of the moon at the moment, because obviously water ice is exceptionally valuable for future astronauts, not just for drinking water, but for potentially making rocket fuel as well. So lots of countries have got their eye on getting to the south pole of the moon to unlock these huge quantities of water ice. And I don't think my machine is going to play ball for some reason. So I'll tell you what we'll do that next week. I'll tell you about the payloads next week. The launch of the IM-2 on a Falcon 9 rocket is going to happen at 17 minutes past midnight on the 27th, that Thursday, early in the morning. So we hope you can join us for that live coverage. We are going to go live at midnight on the 26th. That's Thursday, Wednesday into Thursday. So we hope you can join us at midnight on Wednesday, tomorrow night, where we will, if all goes well, get a fantastic launch out of the Falcon 9. We're pretty optimistic about that because, as you know, the Falcon 9 has an incredible reliability record. So we're hoping for a perfect launch. And then the landing of the IM-2 lander on the moon is going to occur sometime during the first week of March. We think at the moment it's projected for the 6th of March, but we will obviously keep you updated on that. Keep your eye on the channel to see when everything's happening on Space Oddities coming up over the next few days. And we've got the landing of Blue Ghost, as Michael said, on the 2nd of March. And just a reminder that on the 18th of March, Tuesday, the 18th of March, we're going to be joined by Gurbir Singh, who's a space writer who's written several books. Yep. One of them is about the history of the Indian space program, which I thoroughly recommend. It's a great book. And Gurbir is going to come along and talk to us about the present of the Indian space program and its future and what India hopes to get up to in the future in space, what its aspirations are. So we've got all that coming up for you. I think it's time to draw things to a close this evening. Sorry, we've had a few technical problems this evening. We do get them occasionally. It's technology. What can I tell you? Nothing always works, of course. So we'd like to thank you all for joining us this evening. Nice to see some new faces this evening. We will be back next Tuesday, as always, at 8 p.m. UK time. Don't forget the Space Oddities website in the meantime, where you can find out everything that's going on. And that is spaceoddities.space. And don't forget the Facebook group as well. The Facebook group is called Space Oddities Live. You can find that on Facebook as well. Thank you to everybody who submitted images to the gallery. Thank you for your kind donations this evening. Helps keep the ship on course. And we will wrap things up for this evening. So from everybody at Space Oddities, have a fantastic week. And we hope to see you back here next week at the same time. So from Tom, from Roger, from Michael and myself, we'd like to wish you a very good evening. Have a wonderful week, and we'll see you soon.
Good evening.